record. We got to go back, though, for a second. I'm just going to say what the essential question is. How are inscribed angles related to their intercepted arcs? How are the angles of an inscribed quadrilateral related to each other? And then we skipped ahead and we talked about angle B intercepts arc AC. Arc AC subtends angle B, and segment AC subtends angle B. Let me know if you guys need some more time to write this down.
Yes.
Good, okay.
Mr. J. Mr. J, what if we got you mad and started yelling?
I would edit it out.
Edit it out.
Wait, is there any reason why you're recording?
So I don't have to stand up here for 5th and 6th hour doing the same thing. I can just play the video.
Really?
Right, 5th and 6th hour? You're probably hearing this right now. Also, there's some people in 5th and 6th hour that want to stand right by during the hour because they kind of struggle to, take notes.
No, wait, I want to 10.3 was in my mouth.
Wait, can you record something while it's being recorded?
What do you mean?
Like, if you're watching a friend, can you record that? And then, like, talk over
Reception.
it? Like, have a
Oh, yeah.
conversation with everyone.
Can you give us the highlights of 5th and 6th hour or actually your
Oh,
recording?
Oh,
Oh,
this
yeah,
before.
yeah.
yeah, I've done it before.
You should make like a highlight, you know? That is
Okay, so you guys should have this basically written down by now, or it's getting there.
Yeah.
Inscribed angle, an angle whose vertex is on the circle. An arc that lies between two lines, rays, or segments is called the intercepted arc. And normally that intercepted arc is formed by the inscribed angle. Okay, I would for sure get that diagram down. It shows and demonstrates exactly what's happening. So these should be a segment, a ray, or a line. It doesn't matter. It just has to go through the circle at the other part to make this the intercepted arc. Goodbye, little Sebastian.
Oh, okay, yeah.
Should send this recording.
Say the what?
You should
Never
say
know.
like while you're
You say
waiting for
two
them to
seconds.
write it down.
I should sing.
Yeah.
These eyes,
You know that Crinkles for fun.
all cry. But see, now that you guys know that I'm singing, I can't sing. It's like I've got to be doing something different first in order to allow for that.
Is this really?
Miranda, da, da, da.
Can I go get food so I don't get angry?
Is that a threat?
No, it's not a threat. It's
Feed me now. Yeah, go.
Okay.
Take it. Wait, no, you're gonna miss the notes.
Wait, so 5th and 6th hour, are they just gonna be listening to our conversation then?
Yeah, they probably just heard you. Say hi to 5th and 6th hour.
You're not as good as us.
Oh. Shots fired. Okay. Just wait a little bit. We're gonna finish the notes, and then you should be good.
Alright.
Okay. I'm ready to go. We spent 3 minutes 44 seconds looking at this. You know why? Because the recording. That's why. Let's do this. Where's the next button?
This is gonna be a new thing we're doing.
Okay. Here's the theorem. Let's get it written down. I want you to for sure write down this area right in here. This thing. There's no reason you can't get that down on your paper, where we have the measure of an inscribed angle is 1/2 the measure of its intercepted arc. And that's pretty cool. So we have the measure of angle ADB. The measure of this angle right here is equal to 1/2 the measure of arc AB. And we're going to refer to this as the measure of an inscribed angle theorem. Measure of an inscribed angle theorem. This should be written on the board. I'm doing it now. So this is circle C, and we have some point D. That's the vertex of our angle. going over to angle to point A on the circle and point B on the circle.
DAB.
So we have the measure of angle ADB is equal to 1/2 the measure of arc AB. Cool. There's a proof on page 560, example number 37. But if you go to that page and look at that number problem, it's actually just a homework assignment problem that tells you prove theorem 10.10, the measure of an inscribed angle theorem. So it's not really there. That's just classic.
That's lying.
How much?
I think we're ready for our first example.
Angela, no.
Because I have bands. We're going to.
It's game day, Angela.
All right, here we go. First example. First example. We need to find the indicated measure in this circle P. So, we need to find the measure of angle T and the measure of arc QR. Okay, so I know the measure of angle T is equal to 1/2 the measure of arc RS. Measure of angle T is equal to 1/2 the measure of arc RS. What's the measure of arc RS?
48.
So we have 1/2 times 48 degrees gets us 24 degrees. So I know the measure of angle T is 24 degrees. That's cold.
Not if it's like Celsius, that's pretty temperate, that's temperate.
That's cold.
Everything hot.
It's Celsius. It's Celsius.
All right. Now we gotta find the measure of angle. No, the measure of arc QR. So if you look at angle R right here, don't we know that the measure of angle R is equal to 1/2 the measure of arc QT? But that's not going to help us.
Well, wouldn't you just multiply it 1/2 by 50?
1/2 times 50.
Divide, right?
Okay, if we took this angle right here and we did it 1/2 times this equals this right here. We're trying to find QR, which is right here.
Oh.
So
Well, like,
if we drew this angle right here, and we could somehow figure out the measure of angle QTR.
the whole circle is 360 degrees, so just be 180. So you just minus, you got like the QRT.
QTR, is that 180?
No, the T
Isn't
on
it?
it.
Because that's the what is it, the diameter, right?
No.
Yeah, TR is this.
TR.
We know this, and we can find this, so that's why
Oh.
we find that.
Yeah.
Yes.
So we know that this is 180.
Yes.
This whole thing is 180.
Yes.
So this whole thing has to be 180.
Yeah.
But we know this guy right here has to be what?
100.
What's this? How is this 100?
I don't know.
48 plus.
That's
You don't need measure.
Jacob?
Yeah.
So since we found that half of the outside arc is the measure of the inscribed angle. Oh, we can reverse that and say that that's 100 because it's times.
Oh, so this is 100.
Yeah.
Yes.
Can you explain that again?
So
In case
yeah,
people didn't get it.
so since from the outside to the inside is 1/2, from the inside to the outside has to be the opposite, which would be times 2.
I'm getting that.
Okay, so like.
That arc is 100.
This arc is
Yeah.
100?
That arc's 100.
Okay, I can agree with that.
And you know
Alright.
that's 180, so
Alright,
360 minus 280.
Oh, so this has to be 80.
Yes.
Yes.
Yeah.
Alright, cool. So,
So like, alright.
measure of
Yeah.
arc
Oh,
QR.
yeah. You know that.
How do you do it?
It's 50 times 2 is 100.
Oh,
Okay, so since this angle right here, since angle QRT is 50, we know this has to be 100. And if this is 100, this is 180, that means this has to be 80.
How are you going to show it?
Just like that. They can see everything that we're watching right here, and they can hear everything we're saying. So I'm just gonna play it.
But is he using that?
Wait, what about
It's just so he doesn't.
You gotta talk a lot.
Mr. J, you were all confused when we were explaining it.
That's fine.
But
Well, now they're
you
gonna be
going to
hearing
do
what
us,
they can hear.
Probably.
because we taught ourselves.
That's
That's
how it should happen.
Oh my
Then why are
Do you guys have any questions on this problem right here?
Yeah,
How
that's
sensitive
sensitive.
is the microphone?
It's probably hearing you guys right now.
Well,
So,
Oh,
if you
I
guys,
like
if
it.
you guys don't have any more questions over this, if you guys want me to go through that one more time, how we got it, I can do that. Or we can go, yes, let's go over it one more time.
Don't do that.
Okay, so we figured out this angle right here by knowing it's 1/2 of that. So we figured out this was 24. Then we figured out this arc right here is 100 because we know it's twice this inscribed angle right here. So we're eventually wanting to figure out this right here. So this right here is 180. So we have 180, and then 100. So we know that there's 280 so far. So this has to equal 80. Cool. Going back, let's go forward. Okay, we need to find the measure of arc RS and the measure of angle STR. What do you notice about angle STR and angle RUS? Blue, what's up?
Well, the RUS is an inscribed angle, and so you know the opposite arc is double the measure of angle. So I think we can conclude that the measure of RS is 31 times 2.
So we're looking at RUS, and we can conclude that the measure of arc RS equals 2 times 31. So the measure of arc RS equals 62. Okay, and we need to find the measure of arc RS, so we did. Do you have a question, Mason?
Well, we were talking about arcs, but I don't know what is the arc mean? Is it the length of that section?
So it'd be
Yeah,
like
I have.
if you took the center of the circle and then you connected this thing right here, you're looking at this angle measure.
The measure.
That angle
Okay.
measure would be 62 degrees.
So it's not the length of the outer part.
No.
Oh.
Okay, so we found the measure of arc RS was 62 degrees. Let's find the measure of angle STR. So we're trying to find the measure of this angle right here, STR. Do you guys see any way that we can solve for that? Don't we know the measure of angle STR is equal to 1/2 the measure of arc RS?
Yeah.
So measure of angle STR equals 31 degrees. Very cool. Do you guys have any questions on that?
No.
Cool. I think we got another theorem. No. I always end up going backwards. Theorem. Okay. So we got the inscribed angles of a circle theorem. if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So angle D right here is intercepting arc AB. Angle C is intersecting arc AB as well, so we know those have to be congruent. I'm going to be drawing this on the board as well. The diagram for this theorem. I think if you get the diagram down, that's about the bare minimum of what you absolutely have to have. So angle D is formed by this. Angle C is formed that. Therefore, we know angle ADB is congruent to angle ACB. Maybe I should be pausing this recording when I give you guys time to.
Yeah.
Oh well, it'll be a really long recording. That'll be good.
You just get to sit in the show.
You'll be.
They test score, turn it up, that's score, I don't know.
Well, you have to, like, you're gonna have to like stand up there and point at stuff and like draw it out, right? Just not.
No, I mean
Yeah,
like
like
later.
some of them.
So you just didn't want to talk.
I'll just be my own hype man, 56th hour. I'll just be like, yeah, this theorem, like I said. Are you guys good with this one? Ready to do some examples on it? Yep. Cool.
Let's do some examples.
All right, given the measure of angle E is 75 degrees, then find the measure of angle F. Huh. Brendan, what's up?
75 degrees.
How'd you know, man? How did you know? Yeah, we know the measure of angle E is congruent to the measure of angle F. Therefore, measure of angle F equals 75 degrees. That's cold.
That's cool, that's cold.
That's cold.
What's cold?
He didn't say that, he says cold.
It's cold.
They're really cold.
Okay, do we need a linear on this? Okay.
Is there any more?
No, we got some more. Alright, I think we're going to do these, and then that should be good for the day. Find the measure of the red arc or angle. So right here, we're looking for angle G. What would be the measure of angle G? Blue. How'd you get that? Okay, so I know angle G is equal to 1/2 arc HF. Therefore, it equals 45 degrees. All right, let's go on to number 2. So we're trying to find the measure of arc TV. Robert,
76 degrees.
equals 76. How did you get 76?
I did the angle of U over angle U times 2.
So you took angle U, 38 times 2
And then I
equals
76.
76. Awesome.
Mr. J, do you know?
What?
ATV.
No. All right.
I'm not sure about
The last thing we're trying to figure out here is the measure of angle X. What do you notice about angle Y and arc ZW? Both angle Y and angle Z intersect
The happy thing.
arc W.
So cat, I hate cats.
What's its
How do you hate
What
cats?
are you doing? Cats are awful. You're screwing me.
So measure of angle x equals. So the measure of angle x equals 72 degrees.
Cats are just awful.
One thing about dogs is they get like
There's
inside.
no good
The
thing.
thing about dogs is they're not cats. And the thing about cats is they're not dogs. All right,
That's very true.
questions on these three problems? No. Let's see, are there any more examples? Oh, yeah, there it is. Stay focused, stay focused.
Is this the last one?
We still got some more to go. This is the last idea of the day. We'll get some examples after this. Yeah, I regret that. We are getting homework today.
What are we doing tomorrow?
I don't know, what do you guys want to do?
Just like play games.
Go
Yeah,
to
we're
Dylan's.
taking
Shoot outside.
Get fried chicken. Sell fried chicken.
Yeah, what are we doing? Don't do it tomorrow.
Asian king. This king is gonna go. That's his king.
What she did.
A polygon is an inscribed polygon when all of its vertices lie on a circle. The circle that contains the vertices is called the circumscribed circle.
Yeah, I can't see.
Sounds like a personal problem.
Whoa, my lord.
You were also just kind of sitting there.
Yeah,
I want to roast someone.
I was.
Remember that dude?
Harrison, did you say I want to get roasted right
No,
now?
I didn't say I want to get roasted. I said I feel like roasting someone's head right now because that story you told us.
Like a
Where
peanut
you're
head?
like, you look like a peanut head.
Harrison, biscuit head.
Biscuit head. What does a biscuit head look like though? Like that doesn't
Kinda
make
like
any
your
sense.
Kind of look like a biscuit head. Like a two-piece with some honey packets.
Alright. I take that.
What was that about wanting to get roasted?
I didn't say I wanted to get roasted.
No, he said.
I said I was because I thought about that dude.
Now you're like a roasted peanut head.
You got me.
Yeah,
You got me good.
We're not allowed to laugh at them. Alright, are we ready to go on?
Yes.
Yeah.
Yeah, let's go.
Okay.
I like to jump.
Oh my God. How do you think Fifth and Sixth Hour are going to respond to you guys
They're
being
gonna go,
extremely transparent with how you feel about this?
They're gonna feel the same way.
Alright, well, I don't really care. So, inscribed right triangle theorem. If a right triangle is inscribed in a circle, then the hypotenuse of its is diameter of the circle? I'm going to restart here. The name of the right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. Oh, very nice. Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle, and the angle opposite of the diameter is the right angle. Just think about it. If you're going to put a triangle in a circle, like you're going to inscribe it in a circle, then the diameter would have to be its hypotenuse, because that is the largest chord in the circle. Because remember, a chord is just connecting 2 points that lie on the circle, right? So the diameter is like the longest chord that you can get for a given circle. So if we have a diameter, then it's the hypotenuse. Inscribed quadrilateral theorem. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Huh. Its opposite angles? So what kind of quadrilaterals can these be? if its opposite angles are supplementary. They would have to be. No, they have to be rectangles, basically. Because if their opposite angles are supplementary, that means the opposite angles are, oh, not necessarily a rectangle, never mind. It could be a kite, just that the opposite angles, or the sides opposite of each other, they have to be supplementary. So we know they're congruent, but they also have to be supplementary. Only if they're a parallelogram do we know they're congruent. So you just have to have this one supplementary to this one. I wish there was like a supplementary marker rather than a congruent marker. Should I let 5th and 6th hour just use headphones and laptops?
No.
That'd be very
Oh,
boring.
yeah. No one would listen.
You want them to all laugh at once, not like, ha, and then, ha, okay. Yeah.
Good. This is gonna take like an hour to upload to YouTube.
You do it on YouTube?
Yeah. I don't know yet. Probably something about
Can you call it?
1024.
Say, totally random.
It's 25 minutes long.
Awesome sauce.
Happy keeper.
Alright, are you guys ready to go on?
No.
Do you guys write down every word?
Yes.
Yeah. Why? That's too many.
I know,
I'm making this available to you in so many different places.
On YouTube, on your website, and class.
Yeah.
Actually, this guy.
I literally, like, for like a long one, I write down the picture.
Very soon.
Maybe it is kind of good.
It's not cold though.
What's FPS?
Frames per second.
Oh, really? Oh, but, oh, really?
Are you running 60 frames per second?
Not cold.
80.
Frames per second?
You know your eye can only perceive like 29 frames per second? Or like if I flashed you different pictures at a rate of like 20 pictures per second, you would see something like, it would look choppy to you. But have you ever been watching like the NCAA tournament and seen a replay that's in slow motion and then like this is happening or the lights are flashing? It's because the slow motion camera is capturing the LEDs that they go once so every second they go 60 times in 1 second, and the camera captures fast enough to see it flashing 60 times per second. So when it slows it down again, you're like watching the lights flashing.
Fun.
Yeah, okay, cool. So, find the value of each variable. Oh boy. So this thing right here, this side length right here, what do we know about it in terms of its relation to circle Q? It's the diameter. So, since this is the diameter, what do we know about it in terms of the triangle? It's the hypotenuse. So we know that this thing right here, the angle that's opposite of the hypotenuse has to be our right angle because these two have to be our legs. Right?
That's
Okay, so if this is the right angle, we know that 2x equals 90. So x has to equal 45 degrees. Not degrees, just 45. All right, you guys ready to go to the next one?
Yeah.
Okay, what do we know about opposite angles in a quadrilateral that are inscribed on a circle? What do we know about angle Z? Or sorry, Z and 80. What do we know about Z and 80? Blue? Yeah, we know they're supplementary. So we know Z plus 80 equals 180. So what does that mean about Z?
It's 100.
So Z equals 100 degrees.
The other side, y.
Okay, and then we know that Y plus 120 also equals 180. So we know that Y equals 60 degrees. Nice. Nice. You guys need some more explanation on that?
Yeah.
See, these are what the theorems were over, and if you're just writing that theorem down word for word, you might not know that this is what it was going to translate into. Okay. Let's just, let's call it a day. Right there. Great. Bye, everybody.